Hello guys, welcome to my channel. Welcome to this video, which is the first video for paper 2 final exam preparation series. I hope you've watched all the videos for paper 1 and I'm glad to have you on board for paper 2. I believe that you are a subscriber. If you've not subscribed yet, please hit that subscribe button because you'll be helping me to reach as many students as possible out there, and also you will continuously benefit from the channel. So if you feel that there's value in this channel and the material is definitely benefiting you academically, go ahead and just hit the subscribe button. So yeah, what are we going to interact with in paper 2? We have analytical geometry, Euclidean geometry, trigonometry, as well as statistics. All right, and we will be using the 2020 IEP paper that was written then, and definitely it will set us up for success, knowing how the exam is laid out and just how questions are asked. And obviously you'll never see this paper ever again, but it becomes a reference point. It becomes a reliable basis from which to anticipate what is to come. All right, so yeah, let us go for it. Question 1, here it is. Great stuff. So we are given 3 points and we're told that they lie on the same straight line. What does that mean? It means that points are collinear. In other words, if I take the gradient of PQ and I also calculate the gradient of QR, they should be equal, okay? Or I can take the gradient of PQ and the gradient of PR, again, they should be equal. And lastly, I can calculate the gradient of QR and compare it with the gradient of PR. They should be equal, all right? That is the property of collinearity of a set of points that are given, which are on this particular line. Okay, so that is then the method that we are going to follow to answer this first question. So we know that the gradient of PQ will be equal to the gradient of QR. The only variable that's there is A, and one equation will be sufficient to solve for A, as is the question. All right, so let us do it carefully. 4 minus A, negative 3 minus 2. Okay, let us ensure that we apply the equation, the formula correct for the gradient. Is you're changing y, we're changing x. Sometimes students swap those quantities, and you find that obviously you won't arrive at the right answer. The gradient of QR, we are now there, 8 minus 4. Changing x, 1 minus negative 3. Okay, so we leave that 1 for now there, and we'll have negative 5 equal to 4 over 1 plus 3, giving you 4. Okay, cross multiply, we have 4 minus A equal to what? Multiply both sides by negative 5 times the 1, it gives you negative 5. Okay, and then we transpose, we have 4 plus 5 equal to A, and therefore A is equal to 9. So that's it. This takes care of question A under question 1. Right, let us go to question B. Great stuff. So we are given point S and point T, and we are asked to find the equation of the line that is perpendicular to ST and passes through the midpoint of ST. So those are your keywords, the key terms in the question. Okay, what do you know about perpendicular lines? Bring this guy here. Gradient of the line times the gradient of ST must be equal to negative 1. Okay, midpoint, what do you know about the midpoint? You can find the coordinates of the midpoint as the sum of the x coordinates. 4 plus negative 2 is just 4 minus 2 over 2, and 8 plus 6 over 2 like that. Okay, so what do we have? The midpoint of ST, okay, is what? 2 over 2, it's 1, and then we have 14 over 2, that is 7. Okay, so let us now come this side and get the gradient. Okay, gradient of the line, we don't know it, but we're going to multiply that with the gradient of ST. 6 minus 8 gives you negative 2. Negative 2 minus 4 gives you negative 6, which is equal to negative 1. So actually we have 1 over 3 times the gradient of the line equal to negative 1, and therefore the gradient of the line is equal to negative 3. Good. So what can we do? We know that the standard format of the equation of a straight line is y equal to mx plus c. So this guy will come in there, okay? The x will come in there and the y will come in there to solve for what? C. Okay, so we have 7 equal to negative 3 times 1 plus c. Negative 3 becomes a positive 3 there, and therefore c is equal to 10, and the equation of the line is therefore y equal to negative 3x plus 10. Straightforward, no problems detected there. Okay, good stuff. Let us go to C. Here you go. Right, so in this question, we're given a triangle in a Cartesian plane with 2 points that are indicated on it, D and E. However, we're given the equation of 2 lines, AB as well as CB, and it's good to always write them in standard format so that you can read off what is the gradient, you can read off what is the y-intercept. Okay, and we're given a set of points there, D and E. So the question is asking us to show that the line DE is parallel to the line AB. Okay, what do we know about parallel lines in terms of gradients? Their gradients are equal. So then that becomes the logic behind the method that we're going to employ. Already we know that the gradient of AB is equal to 2. This is given. Okay, what is the gradient of DE? 3 minus 1 over 7 minus 6. And this gives you 2 over 1, which is equal to what? 2. Is it equal to the gradient of AB? Yes. So therefore, we have that AB is indeed parallel to DE because of equal gradients. Okay. So in analytical geometry, it is not compulsory for you to state the reasons for your statements. But if you do so, it is a good, practice because it does demonstrate that you know what you're doing and you understand what you're doing. So you can just leave it there because already it is very clear from the calculations that the gradients are equal. All right, good. Let us go to the next question. Have a look. Okay, so in this question, we are told that D is a midpoint of AC. Okay, so it means AD is equal to DA. But in the previous question, we have proven that DE is parallel to AB. Now we are told that D is a midpoint. So by midpoint theorem, E becomes a what? Good, a midpoint as well. Okay, meaning that CE is equal to EB. Okay, what are we looking for? The coordinates of B. Again, from the previous question, we were given the equation of this line CB, and C being a what? A y-intercept. What was the y-intercept there? It was 0, 2. Okay, that is it. So we are moving from midpoint to endpoint. Okay, you must know both directions. If you're given the endpoints, how do you get the coordinates of the midpoint? If you're given the midpoint, how do you get one of the endpoints? All right, good. So that will be straightforward because we have the full set of coordinates there, the full set of coordinates there. We know that 7 is equal to 0 plus x, okay, is coordinate of b over 2, right? Multiply that both sides. We have that the x coordinate of b multiplied by 2 both sides, it will be 14. Let's go to the y coordinate. 3 is equal to 2 plus the y coordinate of b over 2. Multiplication by 2 both sides, we have that, and therefore the y coordinate of b will be 4. Okay, so therefore the coordinates of b are 14 and 4. Makes sense, all right? And obviously this is an increasing function, it's going up. So if that y coordinate is a 3, it makes sense for b to have a slightly more slightly greater y coordinate in terms of numerical value. So it's a 4. And that's how you can check and test your answers as you go along with your solutions. Right. So let us go to the last question under question 1. How does it look like? It looks like this. Okay. In this question, we are asked to find the magnitude of angle CBA. So angle CBA, and there is a B right there. Okay. So relative to the x-axis right here, what are we going to do? We can produce a horizontal line which is parallel to the x-axis. Okay. So we shifting the x-axis up, if you may, and extending the lines. Okay. And you will see that this angle is vertically opposite to that angle. So how can we go about working out that angle? We see that there's an angle of inclination there, there's an angle of inclination there. Okay, we're going to call this one alpha, that one we'll call it beta. Okay, so alpha is the angle of inclination for BC, theta is the angle of inclination for AB. It's not quite a straight line, I'll make it a bit much straighter, but yeah, there we are. Okay, so we know that if we take theta minus alpha, it will give us the magnitude of angle CBA through vertically opposite angles. Okay, good. So let alpha equal to angle of inclination for BC. Okay, and let theta equal to the angle of inclination for AB. Okay, so don't just introduce variables there or symbols. We need to talk about them and explain what they mean. Okay, so it means that angle CBA will be equal to theta minus alpha. Okay, there's a formula that helps us to link angles with the gradients. Okay, so what do we know? Tan of alpha is equal to the gradient of BC. Okay, and what would that be? The gradient of BC was what in the previous question? 1/7. Okay, and tan theta is equal to the gradient of AB, and this one was E2. Okay, so now we are going to take our calculators and find the magnitude of alpha. Tan inverse of 1 over 7 is 8.13 degrees. Theta, tan inverse of 2 is 63.43 degrees. And you want to now subtract the 2 to get 55.3 degrees. Okay, so this takes care of this type of questions, and usually it does become simpler if you just create a horizontal line and sort of shift the x-axis up, and then you're still dealing with angles of inclination. And it's usually a standard question, it's mostly there, and it's one of those that you definitely want to master. Okay, so guys, this takes care of question 1 under paper 2. I definitely believe that this was helpful. We're now heading off to question 2. See you on the other side. Sharp, sharp.